continue our discussion on infrastructure of e-business. So far we have discussed about what is internet and what is the basic web system architecture and what are various performance parameters, how a web information system should be judged, and this particular lecture we are going to learn about networking resources. So, basically we will be covering two things, one is ISO OSI reference model and how TCPIP protocol implements this particular model. So, coming to this computer network, it is a set of communicating computing devices consisting of many basic building blocks. First of all, it has to have a framework under which we are going to talk about various standard organizations who are responsible for setting up many organizations who are responsible for setting up the standards. Then under this we are going to talk about this ISO OSI reference model. Then we are going to talk about the protocols, hardware and physical connectivity. In fact, this hardware and physical connectivity we will be talking when we discuss about computer hardware. There are many standard making bodies like ISO, IAB, IEEE who are responsible for setting up the standard, because of which we are able to make two heterogeneous systems communicate with each other. They are responsible for designing protocols as well as computing devices and setting the communicating devices and setting up the standards, so that we can make two different systems talk to each other. So, if you look at the basic model of communication for basic model of this client server based data exchange over the web, the reference model proposed by these organizations, this specifically this ISO is this open system interconnection model. So, this is called a reference model of the computer network, because this simply shows how logically various activities of a network should be separated from each other. This is just a reference model, and when it comes to implementation, this can be implemented by different protocols. Now, in this reference model, if you can see, there are 4 lower level layers who are responsible for transport service, and there are 3 upper level layers who are responsible for organizing and presenting the content. So, lowest level is your physical layer, where the data actually moves through the physical medium like your cables and all. So, here the data is treated as a bit stream, and along with the data your various various other addressing schemes or physical level addressing schemes are used to send it between two systems in certain manner. Then the second layer is actually your data link layer. This controls the this acts as the flow control on the physical link. Now, it also has certain kind of functionalities for detecting the error if at all it occur during the physical flow. Next level is your network layer. So, in this network layer, network addresses are attached to the hosts, so that they can be uniquely identified over the internet. So, the routing and switching are two activities which takes place in this particular network. Then there is transport layer, which is responsible for end to end delivery and error control. Besides these 4 transport layer, 4 transport service layers. After the data reaches at the client's machine, then it is the responsibility of the server to bring it to a presentable form. So, in the application layer, presentation layer and session layer takes care of these facts. The session layer's activity is authentication, providing permission, session restoration, etc. For presentation layer, it is encryption and compression, and in case of application layer, it is building a human machine interface for understanding what is sent through this transport layer. Then the question is, why do we need such a model? Now, this particular model, which was originally intended as a benchmark for international standard organization of computer networking protocols, has been implemented in various forms, but the idea of logically separating various activities within the layers still remains the same. So, it follows a divide and conquer approach. The layers are used to isolate groups of related functions, so that development and flexibilities are promoted through the use of well defined interfaces. Each layer is insulated from the addressing detail used by the layer below. Various networking protocols and protocol suites can be designed and compared in the framework of this model, and they can be made compatible if all of them follow this model. Now, to implement this one in today, TCPIP is the most important protocol suite. This TCPIP protocol suite consists of 4 layers. If you look at this, they are actually correspond to the, all of them correspond to 3 of them correspond to the transport layer of this, transport service layer of this ISO OSI model, and the upper one is for the application layer. So, the activities are fairly the same. Link layer, they provides the interface access to the physical part of the network, and I mean it basically it connects the physical network with that of the upper layer network. Then network layer is responsible for forwarding the packets in the right direction. Transport layer provides end to end transport service between 2 hosts, and application layer provides a specific application like that of your HTTP and all. So, if you compare this TCPIP and OSI model in right context, we can see in TCPIP here in the network layer, in the data link layer, it has some logical link control protocol and medium access control protocol, and physical layer is not a part of this TCPIP. Then in the IP layer, it has 2 protocols, internet protocols and ARP protocol. Then in the transport layer, it has TCP protocol and UDP protocol, and there are many protocols which are in the application layer. So, if you look at this, in all these application layer protocols of TCPIP, these corresponding session layer, presentation layer or application layers are put together. Now, when the data passes through, first of all let us look at this. When the from host 1, let us say your company server, the data packets are sent to the host B, that is your client, or maybe it may be another server. The application data is sent through all these layers. Each host will be having its TCP, all its TCPIP layers. However, when the data passes from the server, how the data goes? Data goes from server to through various routers, it will be reaching the final destination. So, these routers basically implement only the lower 2 layers of TCP/IP, and the data packets comes here, it goes through a number of routers, then again it passes through all the layers in the receiving host, then the application data which was sent from here gets regenerated at the host. Now, for making this transmission possible in the right manner, while the data passes from application layer to the lowest layer, like here from application to the lowest layer, each time some header is attached with the data. At the application layer, some application header is added. After addition of the application header, it is called the data stream. Then after that, in TCP layer, again along with the application layer header, some TCP header is added. Then it is called a data segment. After that, along with these two headers, one IP header is added. Then it is called a IP datagram at IP layer, Internet Protocol layer. Then in the next layer, in the link layer, along with these three headers, IP, TCP and application header, one link header is attached. So, when the data passes through all these layers, each layer some header gets attached, and when it passes through the router, the last two layers, that is link layer and IP layer, those headers are removed and checked. By checking those headers contains the addressing details. So, seeing this addressing details, your router can now route these data packets. Again, when it reaches the final host, because IP layer contains the IP address which is unique for each machine, once it reaches this point, the host B, each of the layer gets removed, each of the additional header which added gets removed, and finally you get the data. So, by this I mean when you again go up, first at the link layer this header is removed, then at this layer IP header is removed, at this layer TCP header is removed, at application layer application header is removed. So, this is finally this application data reaches the host. So, let us look at the typical activities at each layer. This link layer provides access to the network. It addresses the physical characteristics of the underlying physical layer. Physical layer can be a coaxial cable, it can be some kind of optical fiber cable. So, what kind of protocol, how to handle this individual physical layer components and what kind of protocol will go for managing it is taken care of by this link layer. Now, it handles many access control protocol, each protocol for each of the physical network standard. What are its functions? The encapsulation of IP datagram into forms. By encapsulation of IP datagram, we mean that when the data comes to this layer from the sender, by this time 3 headers have been already added. One is application layer header, second one is your TCP header and IP header. So, with all these 3 headers, it is called a datagram, it is called an IP datagram. So, it encapsulates this IP datagram by adding one extra header, then it is called a data frame. Now, mapping of IP address to physical address is taken care of by this layer, because again the IP address over the internet, when you communicate with IP address, you are uniquely identified within a specific network. Each computing device has its physical address. So, there is some mapping between this physical address to IP address need to take place. Then in the network layer, we have one protocol which is called Internet Protocol. This Internet Protocol, as we have seen, this defines a datagram. By datagram, we mean the data that the sender is sending plus application header plus TCP header plus IP header. taking all these 4 things together, we define a datagram. Now, this defines the internet, this layer defines the internet addressing scheme. Now, moving the data between network layers and transport layers is the responsibility of this protocol. It helps the network address that is attached here helps in routing the datagram. Now, performing segmentation and reassembling of datagram while sending from the sender, while getting from the sender and receiving at the other end, these activities is carried out in this layer. This is a typical IP address format. In fact, IP addresses, there are 2 types of IP addresses. One is your IPv4, which is a older format, which is a 32-bit address. Then you have IPv6, which is a 128-bit address, which is a newer form. In fact, this IPv6, the number of bits are 128, and it is so large that a large number of computing devices can be attached now to the internet. Then we have this IPv4 format, in which there are many fields. So, though because we are not going to discuss about details of this IP etc., but at least 2 things I would like to let you know about here is that this contains this source address as well as destination address. This source address contains the IP address of the source, and destination address is the IP address of the destination. So, the routers, when the data packets are sent, the routers in between know that it is going from which address and it is going to which address. If you look at this here, each of these, this source address as well as destination address IP address are of 32 bit, 0 to 31. So, they are of 32 bit each. So, therefore, we say that IPv4 is a 32 bit address. Now, when last class we discussed that this IP addresses, every system in the internet are uniquely identified by its IP address, and the converting this IP address to corresponding domain name is done by domain name system. Now, this IP address in a dot decimal format has a form consisting of 4 parts. It is a 32 bit address. So, 8888 8 bits on each. So, it is it has 4 parts, 4 8-bit parts. So, a part of this thing within this IP address is treated as the host number, and a part is treated as the network number, and accordingly the network's structure, local network structure is decided. Now, this coming to this transport layer, in transport layer we have 2 protocols, TCP and UDP. TCP, which is called a transmission control protocol, is a connection oriented protocol. It relies on handshaking for maintaining the end to end connectivity. Then it has this source port, destination port and sequence number and acknowledgement sent within its header, within its header, so that corresponding the connectivity between corresponding sender and receiver can be maintained. It uses a sliding window mechanism. So, now let us try explaining these terms in a more lucid manner. As I have told you, is internet is actually a connectionless, HTTP is actually a connectionless protocol, which means it does not maintain the state. So, if we look at the TCPIP protocol stack, above TCP you have HTTP. So, because HTTP is stateless, how does the when you send the data in data packets and make it into small groups, how is it possible that HTTP can I mean when you send the data packets to the other host, all of them are put together? Now, let us try to understand the process of making this connectivity possible. See, internet is it is a packet switched network. There is no connectivity like a telephone network maintained between two hosts. So, and moreover there is one more problem can happen. For example, suppose in your machine you have opened two browser instances that way two tabs in the same browser. Now, from one tab or one of the browser instance you send some request, and second browser instance you send another request for another web page. So, whenever these responses come, that the web pages come, they come to the right tab or the right browser instance. So, how does it happen? Each computer is uniquely identified, that is fine, but within that computer there has to be some mechanism again which can identify these individual web pages which are coming to different browser instances. So, here this concept of port comes in. Each browser instance is associated with a different port number. So, even if you send from the same computer from two browser instances, even if you send when you send two requests, they not only come to the same machine, but they also come back to the same browser instance. So, this is the role of the port. So, each application networking application running has a unique port number associated with it. Now, let us try to understand the meaning of handshaking and how connection is maintained. Connection between the sender and receiver is maintained through handshaking. Now, through handshaking, as the name indicates, first the source, the sender sends a message to the destination to find out whether the destination is active or not. Then if the destination is active, then the destination sends back a response, it shakes the hand. Then the source once again confirms that it knows the destination is up and tells the destination that it is going to send the data packets. Then the data packet, then afterwards the destination is prepared that some data packet is coming from such and such source. So, data packets keep coming. Now, as we have already told last class, internet is a best effort delivery network. That way, every packet switch network is a best effort delivery network, which means due to network congestion, if some of the data packets are lost, it is not network does not take any responsibility for that. It is the responsibility of the host to resend these packets. Now, the question is how the host will be knowing that data packets, some of the data packets are lost. So, for that purpose a sliding window mechanism is implemented in TCP. So, in a simplistic manner, this sliding window mechanism is the one in which because once the sender sends some data packets, it will be receiving some acknowledgement from the receiver. So, from the receiver's acknowledgement, it can realize up to what number of data packets it has received. So, if it finds that it waits for some time, and if it finds that for certain number of data packets, the response is the acknowledgement is not received, then it immediately sends another chunk in a sliding window manner, and first 10, next 10, and if something is not responded, again it goes back and starts sending from the one for which the acknowledgement is not received. Now, this process though helps in making the connection possible between two resources, two hosts, because of this handshaking and maintaining connection, it is a bit slower protocol. Correspondingly, there is another protocol in the transport layer which does not make this connection possible. So, this particular protocol is called user datagram protocol. So, this is a connectionless protocol. This does not waste time in handshaking, but it has this source port and destination port attached with its header, so that the packets can be routed in the right direction and reach at the targeted application. It does not send any acknowledgement, but it is fast. So, while sending the data where the sequence need not be maintained, or if a part of the data is by chance lost, it can be managed, then UDP is used. Just imagine that a big map is being sent or some huge image file is being sent. If the image file is little blur because it has not all the data packets related to the image file is not received, then it is acceptable. But if some text message is sent and a part of the text is missing, then it is not acceptable. So, you can understand what is the implication of TCP and UDP. This is a typical TCP and UDP format. Here there are again many elements, many header elements, but what we are actually talking about so far, it is the source address and the destination source port address and destination port address, which after the data packets reach following its IP address, it reach the right host, it is targeted to the right application. Then this sequence number is very important, because you are sending the data sequences and it is the responsibility of the TCP to see that, to maintain the connection, to see that all the packets in the sequence are reached at the destination, and this acknowledgement number is something which comes back from the receiver telling that what all has been received so far. Then there are other controlling header elements which we are not going to talk about, but if you look at this UDP format, what is missing here is this sequence number and acknowledgement number, but the source port and destination port is there. So, it is ensured that if at all the data reaches at the receiver, if it is not lost in between, definitely it will reach the right application, but if something is lost in between, the sequence number and acknowledgement numbers are not maintained. So, it is not the responsibility of UDP. Then next layer is your application layer. One of the application layer protocol we have already discussed about HTTP, which is a stateless protocol. There are other application layer protocols as well, like FTP, Telnet, SMTP, etc. We are not going to have a lot of discussion on them, because we are mostly interested in the HTTP protocol and sometimes possibly FTP for large file transfer, etc. Now, as I was telling you, each host in the network is uniquely identified by the IP address, and each application within the host is uniquely identified by a corresponding port. So, if we put this port number and IP address together, we call it a socket. A socket is a combination of IP address and port number. So, your protocol number, besides this you also have the protocol number to identify the transport protocol, you have port number to identify the application, and along with IP address, your once a request is made from the host from a specific client or the browser instance, it reaches the destination and the response is sent back to the right application, not only the right host, to the right application as well. Thank you very much.